This is checkpoint 2.56. We want to convert the point -8, 8, -7 from Cartesian coordinates to cylindrical coordinates. Okay, let's get an idea of where this might be. This looks like it's going -8 and +8, and it goes down 7. So given that this is your x, your y, and your z, we went negative direction, -8. We went positive direction, +8. And then we went down 7 units. This is your point. Now when we're looking at this point, -8, +8, -7, and we're going to try to transform that into cylindrical coordinates, it turns out that the z is going to be the z, and then the other two are going to be some cylindrical coordinates that would be describing -8 and +8 in 2 dimensions. So I guess that's essentially polar coordinates that we're looking at. Okay, so just to remind us of some of the formulas, we have x is equal to r cosine theta, y is equal to r sine theta, and z is equal to z. So if we had r and theta, getting the x and y would be quite easy. But if you're going backwards, we have to go a slightly different way. And the other formulas that are involved there in polar coordinates, if you remember, was x squared plus y squared is equal to r squared, and theta, or the tangent of theta, is equal to y over x. But we might be better to kind of look at it graphically instead, to give us some idea of what this point might be. So let us bring ourselves to 2 dimensions, and this is our 2D view, x and y, and the -8, +8 would be the point over here. -8, +8, and so we just need to figure out our r and our theta. First, let's figure out the r. R is radial distance. I think that part is pretty straightforward. We have -8 squared plus 8 squared is equal to r squared. So r squared is going to be 2 times 64, 128. And then r is going to be the square root of 128. I think that's 8 root 2. We can leave it like that. The next thing we want to find is our angle. Our angle from the positive x-axis would be, it looks like it's the same x and y points, so I think we're looking at some multiple of pi over 4. So that's 1 pi over 4, 2 pi over 4, and I think this is going to end up being 3 pi over 4. Okay, I think it's a little bit easier to do it this way if you have nice numbers that are, one of your major angles. Okay, we have our theta, we have our r, and we have our z. So then our equivalent point from Cartesian coordinates of -8, 8, 7 will transform into polar and cylindrical by this square root of 128, 3 pi over 4, and -7. Okay, now if you didn't already notice, there's a lot of ways to get to this angle. There's 3 pi over 4. If you add 2 pi to it, you're going to get to 3 pi over 4. If you go from the negative side, you're going to get some other angle. So there's many different answers to express in cylindrical coordinates, but usually the best angle to choose is some angle between 0 and 2 pi, and 3 pi over 4 is certainly one of those angles. Okay, I hope that helps.